Okay, so this is going to be the first of 4 short videos relative to Unit 3, Day 3 for Algebra 2. In this first video, I'm briefly just going to go over um, how square root and parabolic functions are inverses and basically how to calculate them. We've already been introduced to how to calculate inverses of square root functions in do nows and just by proxy and other assignments that we've had. But all the same, this is our first time like actually focusing on it. So first, let's calculate the inverse of g of x here, right? And remember, our process for this is to always flip dependent and independent. So instead of g equals, we're going to say x is equal to, right, 2 times the square root of g. Okay, so now all I'm going to do is resolve, quote unquote, for the dependent variable. And once I get g by itself again, that resulting function is going to be my inverse. So I'm going to divide by 2. I'm going to square both sides. Right, and I can express it this way that I've got it, or I could also say that this is 1/4 of x squared. Just so that way I know, I've got this transformation here, which is a vertical shrink uh, by a factor of 4. Okay, so not too concerned with how you express that, just an FYI that you could do either one. Okay, so let's look at this next example where we're calculating the inverse of h of x, right? So h of x is a little more complicated, as you can see, but all the same, it's going to still require the same work. So I'm going to flip the variables. So it's going to become x now equals 1/3 times the square root of h plus 1, all minus 2. I'm going to add 2 to both sides, multiply by 3, right? Or you could just kind of leave it outside of the parentheses. That may actually be what I want to do instead. So I'm going to multiply by 3 and just leave it as 3 times x plus 2. You don't have to distribute. And then I'm going to square both sides. So now I've got 9 times x plus 2 all squared. And that way now I have it in vertex form. Right? So that would be my inverse there. And now let's look at the geometry of this. So just to kind of prove a point. So here's the first function. And then let me make this smaller. So right now we're looking at g of x. Is it really not going to let me fit it in the window? Let's see. There we go. Should have probably done this beforehand. But anyway, so here's g of x. So 2 times the square root of x, right? And we see, oh, it's not going to let me do it anymore. We see that when we input the inverse, right, we don't really quite see any symmetry, but then once I throw y equals x in there, well, it's plain as day that they are symmetrical about the line y equals x, and therefore they must be inverses. Okay, so let's look at h of x now. Okay, so h of x, I might as well leave this one full screen. We see it's right here, and it's inverse. Okay, symmetry is not so obvious. And I'm going to do something just to prove even more of a point. Symmetry is not so obvious yet. Then when we throw in y equals x, it gets a little more apparent, but still not quite. So I'm going to also include the negative version of this. Okay, now it is painfully obvious that these are symmetrical about the line y equals x. Okay, and of course, in geometry, we're only thinking in terms of magnitude, but in algebra, we have to remember the duality of squares always. Okay, so that does it for this video. Pretty simple stuff, not really anything new there. If you have any questions, obviously let me know. Goodbye.